No way.
Here, I'll move. No, you can have a chair. I'll move this up out of the way. You don't have to sit in my lap.
I guess
Can I get you to make some copies? Oh, yeah, I never had to do anything. And I do have something today if you wouldn't mind.
Oh.
All right.
Oh my god.
Light orange ends. So once the purple is gone, I have mine. I'm gonna dial these blue. So I don't have mine.
Okay, so are you good with two-sided and all that good stuff? Okay, so I've got 4 pages, so if you can just do them two-sided and then staple them together, that would be awesome. And I only need 6 sets. Thank you.
Oh crap, it's stuck in my ear.
Are y'all seriously? Jonas, I'm gonna have to be real strict about the mask being up. We got an email about we gotta make sure that everybody's masked up. Because yeah. All right.
Is it just
Let's
us?
like I think it's just the 4 of y'all, I guess. I don't know. Is Sadie here?
Yeah.
I was gonna say, but Sadie just kind of strolls in when she's hope we're not interrupting her schedule today. Sorry. Math can be a burden.
I like that.
All right.
I don't.
Wait, how many people are in person?
It's not necessarily it's the math, it's your teacher that you like that. Isn't that right? Isn't that why y'all are here? Is not for the math, it's for me. Just kidding. All right. So I hope you guys are doing well. Obviously, I'm going to wait for just a minute and see if we have more that join in. I only have 4 people in the classroom. So out of 14,
Why?
because so many people have had to be quarantined. We had some exposures here at the co-op yesterday, and so there's several classes that are quarantined.
Okay.
So anyway, so we have got a lot of students out. So I guess hopefully most everybody will be watching the video. So hello, if you're watching the recorded version later on. But yeah, so right now, evidently Sadie is somewhere in the building. So we're just waiting for her to grace us with her presence. But, anyway, so Sadie is
Who all
somewhere.
is there?
Who all is here? It is just Claire and Katie and Jonas and Grant. They are the lucky 4 right now. They get all of my undivided attention.
Yay!
I was like, we can hear people still there. So.
But you can still be a carrier. That's one of the things that they were talking about. And evidently it stays in your nose, and they call it a nasal flange or something like that. But anyway, so that's the thing that you got to be careful of, is it's not necessarily you getting it, it's you giving it. And so, all righty. So because I did not know who all was going to be in class and who was going to be virtual, I had emailed a packet last night. So for those of you here, I've got copies of it. If you're, yeah, for the four of y'all. The good news is y'all each get 3 copies. I'm just kidding.
Oh my!
You get to fill out 3 of them. So all right, so what I did is the first one is called Solving Systems of Equations Review for Test. So we're going to be looking at our review. The first thing we're going to do is go over homework, and then we're going to start reviewing each one. And we have some practice problems and all that good stuff. So if you have not had a chance to print this out just yet, if you're online, if you wouldn't mind trying to get this printed out while we're checking homework. The first page, Solving Systems of Equations for Review, there's 2 pages of that. And then there's 2 pages of practice that we're going to do today to prep for the test. Okay? So let's go ahead and take a look at our homework. Let me get all of my stuff out real quick. Let's see, my notebook. Are y'all cold?
I'm cold. Although I'm always cold. So. It's like an igloo.
All right.
Yeah.
So on, oh, here comes.
So good.
Okay, so on the 25th, on Monday, our homework, we had corrections to lessons 56 and 58. If you had any work that you did not turn in on Monday, if there was anything that you were short on, well, welcome, everybody. We're all just waiting for y'all to come on in. Where is everybody? Most people are quarantined because of exposure yesterday at the co-op. So there's a lot of people out.
You know.
So anyway, let me go ahead and give y'all, so if you have any work that you did not turn in on Monday that needs to be turned in today, please go ahead and get that out.
I had 3 corrections.
All right, so the first thing we're going to look at is if anybody has questions on lessons 58, 56, or 58. Lesson 56 was dealing with division. 58 was just a review where we were dealing with, you could use whatever system or whatever way that you wanted to use. So any questions from lessons 56 or 58, corrections that you get? Lesson 56 or 58, any questions on corrections? All right, and then our homework was lesson 59, activities 3 on graph paper. So that's where we're going to go ahead and start today. So remember on activities 3 on page 130, we talked about how each of these could all be solved by using how all of these could be solved by setting each equation in slope-intercept form. And actually, I may turn this.
You draw those lines?
No, I did not. I don't know who did this, but it's like sticky. But I am so happy they did. It may be Miss Donna's. I don't know. But it's definitely going to be easier to deal with than that little clingy thing that we used the other day. All right. Sorry. Nope. Well, it's a little wollywonker, so it doesn't want to stay. All right. So remember on each of these, the first thing we did, I've had them fall. Actually, I'll take it down until I'm going to use it so it doesn't fall on my head. Okay, so we talked about how each of these, I got to keep your mask up the entire time. We can't eat because it's just with everything going on. And Mr. Mike said he's going to be coming and doing spot checks of masks as well during the day because they're concerned about the exposures that we've had this week. I don't know if y'all have heard, we're going back virtual next week. So we'll be virtual until we have our winter break, which is the week of the 15th. So hopefully we'll be out for 2 weeks. We'll have winter break. Maybe that'll give kind of time to get everything settled. We'll have time for if there's anything lingering within the building, it will have died by then. And then we'll try again. We'll keep trying in person as long as we can until, so anyway, at least we gave it a shot for a little bit. And
this is reminding me of last.
Yes, it does. It is reminiscent because it was almost this time last year. It was when we left for spring break and we didn't come back. And so anyway, all right. So when we were solving by graphing, remember we said there is the option of always setting up a table. But if I can solve for slope-intercept form, y equals mx plus b, then that's going to always be the easiest way. We've already learned how we can use y equals mx plus b to use when I set my equations. Sorry, I'm throwing markers at you. There you are. Thank you. I can always set them equal to each other using that, but in this situation, they're telling me I have to graph, so that's what I'm going to do. All right, so let's go ahead and look at the first one. Did we have all 6 or did we do any of these together?
We had also.
We had all 6. Okay. So looking around, I should see 6 graphs, but if I don't see your 6 graphs, then I know that there were some people that needed some extra help with somebody at the door. I know there were some people that needed some review time. So these, come in, these will be due. You can, let me move this. You can just sit right here. So know that I will not be taking this homework up today. I'm going to give you time to do corrections on it. So all homework that is not turned in yet, if on Monday you gave me a note about something that was missing or you didn't have something to turn in, every bit of homework from this unit will be due when you turn in your test. If it is not turned in, I will not accept it late and it will be a flat 0. This is your fair warning, okay? I will not give time because I'm telling you now to get all of your work together, make sure all your assignments are complete. Sadie? Yes, we'll end up having to upload it if we're going to be out for the next 2 weeks.
I was about to ask that.
Yeah, so we will end up having to upload it. I will give you a complete list of everything that will need to be uploaded, but whatever you have not turned in to me, I will also let you know, because I know a lot of y'all turned in a bulk of your work on Monday. So before it is totally due, I'm going to say, this is what you're missing. It is due when you turn in your test. If you do not have it turned in when it's test time, then it will be a 0. Okay, so I need to make sure that everybody understands that. All work that is not turned in yet will be due with your test. Okay. So today we're going to review from lesson 59. We talked about first setting up tables or solving for slope-intercept form. So let's go ahead and look at our first equation. I have negative 2x minus y plus 12 equals 0. And then I have 2x plus 2y minus 6 equals 0. Now, immediately when I look at this, if you were not told that you needed to solve by graphing, what would be your immediate reaction to be able to solve this equation? What should you be able to look at immediately that you have?
Divide.
I could cancel these 2 right here. Okay, I could eliminate, but my directions say I have to graph. And when I graph, the first thing I want to try to do is solve for y. Okay, so I can see that this equation, I can solve for y, but I cannot solve my second equation for y just yet. What do I need to do to get y by itself? I'm not kidding. I'm just dealing. I'm forgetting about this right now.
Divide.
I have to divide my bottom equation by 2. So if I divide by 2, okay, so I'm going to have negative 2x minus y. I'm going to go ahead and write these in standard form. And then 2x divided by 2 is going to give me x. 2y divided by 2 is going to give me y equals negative 6 divided by 2 is negative 3. When I move it to the right, it is a positive 3. Is everybody good with that so far? I kept my first equation the same because I can solve for y. But what did I do? Or I haven't moved it yet. So I can solve for y on the first one. This one I have to divide each term by 2. So now I'm going to start solving for y. Negative 2x plus y equals negative 12. What needs to move from the left to the right?
Negative 2.
Negative 2x. How do I move it? I'm going to add 2x, add 2x. So I have negative y is equal to 2x minus 12. What is wrong with this?
Negative.
It is a negative y. What does it need to be?
Positive.
Positive. So if y is positive, what happens to 2x?
Negative.
It becomes negative, and minus 12 becomes
Positive.
plus 12. Is everybody good with that so far? I'm solving for y, and I've got to solve for a positive y. Now, my bottom equation, x plus y equals 3. What needs to move from the left to the right? I need to move x. It is positive, so I'm going to subtract it. So y equals negative x plus 3. These are my two equations here. Let's look at this first one. What is my y-intercept of this equation?
0, 12.
My y-intercept is going to be 0, 12. What is my slope?
-2.
-2. So that means I have -2/1, which is a +2/-1. So these are the things I can graph for my first line. Graph my y-intercept, use my slope to find additional points, connect my line. What is my y-intercept here?
0, 3.
0, 3. What is my slope?
-1.
-1. So -1/+1 or +1/-1. Those are my two options, okay? So let's go ahead and take a look. Thank you. All right. Yeah, that'll be great. Thank you so much. All right, so let me adjust so y'all can see. All right, so obviously for you guys, everything is like reverse image. So I'm sorry about that. I wish there was a way I could figure out how to, for it not to be. So anyway, all right, so what we're gonna do is we're gonna graph this line first. My y-intercept is 0, 12. So that's why I told you guys it would be better to use your big graphs instead of the little ones because you may not have enough room. What I'm gonna do is I'm gonna go ahead. And we'll have, okay, there's our x and y axis. So our first one, we said 0, 12. Remember, start at my origin. I do not go right or left. I go up 12. Hopefully I've got enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay. First point. There's my y-intercept in my first line. My slope is -2/1. Well, I do have a little bit of room to go up, so I can go up to 1, 2, and 1. So there's 1 point, and I can go down 2, right 1, down 2, right 1, down 2, right, down 2, right. Okay, I got all this. I can go for days. Oh, down 2, 1, 2, 1. Okay, so that's as far as I can go. Kind of hard to write when it intersects with these little, there we go, good enough. Okay, so there's line 1. So now I'm going to graph my second line. My y-intercept is 0, 3. Again, start at my origin. I do not go right or left, but I go up 3. 1, 2, 3. There is 0, 3. My slope is -1/1 or over negative. Up 1. So I'm not going to bother going that way anymore because my whole point is I'm trying to intersect this line to find my ordered pair. So down. There it is right there. I can keep going if I wanted to. But I can see now where when I graph that line, I have this point of intersection. So I've graphed 2 lines until they intersect. Now I've got to identify that point of intersection. Remember, my solution is written as an ordered pair. So if I get a paper and it doesn't have an ordered pair, then I have a, okay, and I think I've seen some of that with some homework. We're going to have to, I'll be in touch with you if you need to get anything. I've got some where I still just have equations. I don't have a pair solution. So for my ordered pair solution, again, at my origin, and I look to see, do I go to the right? I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. Where was I? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I went down 1, 2, 3, 4, 5, 6. Down 6 is -6. So my ordered pair solution for the first is 9, -6. Is everybody good with that? Solve each equation for y, y-intercept, use, okay? Any questions on that one? Let's go ahead and look at the next one. What I'll do is I will call for them, and if there are any that you need me to work, let me know, okay? Let's see, this is lesson 59. All righty, so the first one was 9, -6. The next one to the right is -5, -1. Any questions on that one? Do I need to work it? Any questions on the second one? All right, third one on the top. My point of intersection is 7, 5. Huh?
What was the first?
The first one we just did together was 9, -6. That was one we just did on the board. So number 1 is 9, -6. Number 2 is -5, -1. Number 3 is 7, 5. Any questions on numbers 1 through 3? All right, number 4 is -3, 7. Number 5 is -5, -9. And number 6 is 7, -4. Any of those you guys would like me to work?
I did not know that. So we were supposed to solve and then find the point of intersection.
The whole point of graphing is to graph each line and look to see where those lines intersect.
Yes, ma'am.
My point of intersection is my solution. So if you have not done that on this homework, then you'll need to go back and make those corrections. You should have 6 graphs, each where you have graphed both lines and shown where the lines intersect. Okay?
I just never realized I was supposed to write the answer of where they.
Okay, so did you graph them?
Yes, I did.
Okay, so did you circle the point of intersection?
Yes, ma'am.
Okay, did you label the ordered pair for that intersection point?
No, ma'am.
Okay, so that's what you need to go back and do, is just write your answer, okay? All righty. So what we're doing is we're going to be reviewing everything that we have looked at with solving systems of equations, okay? Before we get into it that we've got, what is the point of solving systems of equations? What are we looking for? What do we just say what we're looking for? A point, a function, okay? We've got 2 equations that are lines. We know both linear equations have both an x and y value. When I have x and y, I'm typically thinking coordinate grid, ordered pair, okay? So my whole point of having those 2 linear equations is I want to solve to see if they intersect, and if they do, what is that ordered pair? What kind of lines do I have if I have no intersection points? What do I know my lines are? Parallel lines, because remember, parallel lines will never touch, they'll never intersect. So if I have no intersection point, parallel lines, what if all of my points are the same? What if all points are the same?
Doesn't that mean they're on top of each other and the answer is all real?
Do I have? Solution is all real numbers, okay? So let's go ahead and take a look at brackets that we're in today. All righty. First example was substituting or setting the equations equal. So flip back for just a minute to lesson. If you want to packet, you can. This is lesson 51. So systems of linear equations, and said that we could set. So when I set them equal to each other, I'm actually substituting the mx plus b part of my equation for y, saying that the mx plus b part is equal to the mx plus b part, okay? The first thing says, use this method when you have both equations for which variable? Which variable for? Look at your book. Look at your notes. Look at what it tells you. Which variable does it say to solve for? Okay. Look at the first step. It says find the solution. We said equations in slope-intercept form. So that point 1, you for y. Now remember, we just did that with graphing. Okay, so like in this example, I could have said, and actually let's go ahead and look at this since I've already got it on the board. When I am here, I could have said (2x) equals negative x plus 3. So in this situation, I've said if so I substituted, and now I solve for x. Okay. So step 1 says write each equation in slope-intercept form. In that blank, I want you to write slope form. Y equals mx. Step number 2 says use the blank part.
What was the first blank?
Both equations for y.
Miss Jennifer, what was the very
Yes.
first?
Okay. The first for y. Step 1, slope-intercept form, you're writing y equals x plus b. Y'all good with?
Yeah, it's just the Zoom is really choppy.
Okay, I'm sorry. I wish there was something I could do about it. Number 2. I have to go back any point, okay? Says use equation that I set equal to each plus b. For number 2, plus b variable x. So x. All right. So let's go ahead and do that. Let's go ahead and move my x over here. I'm going to add x. Negative 2x plus x is going to be negative x plus 12 equal 3. Now I'm going to add 12. 3. Take the sign of the larger and find the difference. 12 minus 3 is 9. Take the sign of the larger. So if negative 9, what is it? So that's step 3. X into one of the original equations. I told you I typically always go with the first one. Okay. I'm going to take this equation. I'm going to plug in x is equal to 9. Y is equal to negative 2. Remember, I'm going to put value in parentheses so I can be super careful. So negative 2 times 9. So y equals, what is negative 2 times 9? Negative 18. plus 12. Negative 18 plus 12. Take the sign of the larger, find the difference, negative 6. Okay, so step 4 says plug the value of x into one of the original equations and solve for y. We did that, we solved for y. So now my final step, number 5, write the solution as an ordered pair. So remember, and I put in parentheses beside it, x, y. So I take my value of x, which is 9, y was negative 6, so this is my solution. Solving by substitution or setting them equal. Step 1, solve for y.
What is the
Y
answer?
equals
to-
mx plus b. Huh?
What is the answer to number 2?
Here are the blanks.
Oh, okay. Thank you.
You good? Uh-huh.
Wait, could you show it again?
Okay.
Can you do the whole thing again? Yeah, just erase our name.
Y'all know if I survived this year.
Okay.
Everybody good? All right.
Wait, what's that one?
I'm not gonna say that. All right. Okay. So, solving by substitution or setting equal. Solve for y. Set your mx plus b parts equal to each other. Once I've done that, I solve for x. Once I have my value for x, I plug it in back to one of my equations and solve for y. I have solved for x, I have solved for y, so I write my solution as an ordered pair, x, y. Thumbs up, thumbs down, thumbs sideways. Okay. Elimination. Now, go ahead and turn to lesson 53, I think. All right. Remember we talked about how elimination, my whole purpose with dealing with elimination is I'm trying to figure out how to get rid of one of my variables to be able to solve for the other. And I told you guys that the easiest way to work with elimination is look for opposites that you can add together. Because when I add opposites, that equals 0. So if I have opposite terms, I can add them together to cancel. So there are several ways that I can do this, okay? I have several ways that I can get my equation in the form to add an opposite. All right, bullet point number 1 under elimination. Use this method when you see that you have opposite terms that can be eliminated by adding the opposite. Adding the opposite is bullet point, or you could have opposites. Adding the opposites is bullet point 1 under elimination. Use this method when you see that you have opposite terms that can be eliminated by adding the opposites. Now look at the second bullet point. It says if you have 2 terms that are the same. So what if, so in this bullet point 1, add opposites. That would be like having 3x and negative 3x, okay? Bullet point number 2, what if I had 3x and 3x? What would I need to do to one of those to make them opposites? Multiply by negative 1, right? So if I multiplied one of them by negative 1, then I've got negative 3x and 3x. So I've made opposites. So bullet point number 2, if you have 2 terms that are the same, multiply one of the equations by negative 1. So you will have opposite terms that you can eliminate by adding. This was like lesson 54 that they called subtraction. Okay, so basically in this situation, I could look and I could subtract 3x minus 3x, but then if I don't pay careful attention to all the other signs in my equation, it's real easy to mess it up. So when we were dealing with subtraction, we said, well, hey, what I want to do is I want to change from subtraction to addition and add the opposites, okay? So if I have like terms, then I multiply one of them by -1, multiply every single term by -1. So now I've got an opposite term and I've turned it into adding the opposites. So the first one, I already started with opposite terms I get to add. The second method, I changed to adding to where I can add the opposites. My whole goal is to add the opposites and eliminate a term. Look at the final bullet point under elimination. You may have to blank or blank one or both equations in order to get opposite terms that can be eliminated by adding. What did we learn in lessons 55 and 56?
Multiply or divide.
Multiply or divide. So lesson 55 was multiplication, lesson 56 was division. I may have to multiply or divide one or both equations to get opposite terms. Multiply or divide. So these are three things that I can do to eliminate. First, if they're already opposites, add and go. Second, if they're both like terms and I need to make one the opposite, multiply everything by -1, add and go. My third bullet point, let's say I had 2x and 3x. I could multiply this one by 3 and this one by -2. Or I can multiply this one by -3 and this one by +2. It doesn't matter. But I'm multiplying one by positive, one by negative. So here I've got 6x and then I have -6x. Here I would have -6x and then 6x. It doesn't matter if I'm trying to make opposites. It doesn't matter if I choose one to multiply by a negative and the other positive or whatever. The main thing I'm trying to do is get where I have opposite terms. So again, I can add them up and go on. Is everybody with me so far? All right. So now let's look at our steps. Steps for elimination. What you may want to do is if you want to put by elimination, just put add opposites. Because remember, my whole goal, so what I've done is right there where it says elimination, just out beside it, I wrote add opposites. So that way I can see my whole goal, whether it's to identify that they're opposites, multiply one equation by -1 to get opposites, multiply both equations, or divide both equations to figure out how I can add opposites. That is my ultimate goal. Okay. Step 1 says write each equation in standard form. What is standard form?
X plus by equals C.
AX plus BY equals C. That goes in your first blank. Write each equation in standard form, AX plus BY equals C. Now, step 2 is where I'm actually addressing each of those 3 bullet points, okay? So step 2, if you have opposite terms to begin with, add to eliminate those terms. If you have opposite terms to begin with, add to eliminate those terms. Now, my first little step says if you do not have opposite terms, you can, I put it as a question. If you do not have opposite terms, can you multiply one equation by -1 to make opposite terms? If so, multiply one equation by -1 and then add to eliminate. If you cannot get opposite terms by multiplying by -1, can you multiply one or both equations to get opposite terms? If so, multiply to get opposite terms, then add to eliminate. If you cannot multiply one or both equations to get opposite terms, can you divide one or both equations in order to get opposite terms? If so, divide, then add to eliminate. So we just addressed each of those bullet points that we had at the very beginning. If they're already opposites, add. If they are the same terms, multiply by -1. If I cannot do either of these two, is there something you can multiply by? And then the last one is there something you could divide by? So if I had 6x and 2x and I need to make those opposite terms, I could divide this one by a -3. Then I've got negative 2x and positive 2x. Opposite terms, add them up, move on. Same terms, multiply 1 by negative 1, does not matter which one, just make one negative, okay? Add them up, move on. Multiply one or both terms, find your opposites, add and move on. Divide to make opposite terms, then add them up and move on. The consistent thing here, though, is I want to be able to eliminate by adding the opposites. Sometimes it'll be x, sometimes it'll be y. Whatever is going to be the easiest to eliminate is what you go with. All right, so now let's look at number 3. Once you have been able to get opposite terms, huh?
Can you show us the paper?
Okay. So the first one in our bullet points, add the opposites, then I have negative 1, multiply, divide. Standard form is ax plus by equals c. Then my blanks are going to be add, multiply, multiply, divide. So now moving on to number 3. Once you have been able to get opposite terms and have added to eliminate those terms, solve for the remaining variable. Solve for the remaining variable. You may have eliminated x in the beginning and now you're solving for y, but then you may have eliminated y first and now you're solving for x. Whatever your remaining variable is what you're solving for. Then step 4, plug the value of the variable you solved for in step 3 into one of the original equations and solve for the remaining variable. Write your solution as an ordered pair. Is the remaining variable. Number 4 is equation. Number 5 is ordered pair. Any questions so far? So we've gone through our first method of substitution or setting equal. Our second method, elimination. Third method that we just worked on and went over with homework, but we're going to go over again is graphing. Oh, no, graphing is so much fun. Okay. I will tell you, okay? I think I freaked y'all out by setting up those tables the other day.
Yeah.
I wanted you to be able to see that if all else fails, you can always set up a table, okay? You can set up a table and solve and figure out values. There will not be any on the test that you have to set a table up for, okay? There will be none on the test that you have to do a table like we did on Monday. On the test, they will all be like our homework was, where I solve for slope-intercept, identify the y-intercept, use the slope to graph additional points, show where both points intersect. That's your ordered pair solution. If they don't intersect, they're parallel, so I have no solution. If they lie on top of each other, they are the same line, so all real number solution, okay? But that's going to be in our information right here on graphing. So our last part is graphing. Bullet point, use this method. If you can identify the y-intercept and the slope of a line. These are exactly the same. Graphing and substitution or setting equal to are exactly the same to begin with. So on your test, if I say solve by substitution, then that's what you're going to do. If it says solve by graphing, that's what you're going to do. So my plan is for the test, you'll have a couple that I tell you specifically what to do. And then you'll have a few that you get to pick. So if you don't like graphing and you'd rather solve using substitution, go for it. If you enjoy graphing more than you like solving by substitution, then you can graph. If you can get it into slope-intercept form, you get to choose which method you want to use. Okay? So the first point. Use this method if you can identify the y-intercept and the slope of a line. Steps. Step 1, graph the blank of the first equation. You know what I messed up on? I forgot a step. So where it says steps, okay, so it says steps, colon, go ahead and put write both equations in slope-intercept form. Write both equations in slope-intercept form. So I just wrote that right where it says steps, colon, write both equations in slope-intercept form. Right after the colon, where it says this part right here, write both equations in slope-intercept form. Once it's in slope-intercept form, now I can go to step number 1. And what am I going to graph? What did I do when I was graphing a minute ago? What did I have to graph first?
The ordered pairs.
The y-intercept. So I've got to graph the y-intercept of the first equation. So number 1, graph the y-intercept of the first equation. Yes.
A second ago, when you said graph the blank, almost like blank.
Graph the blank. All right, number 2, use the blank of the first equation to identify additional points on the line and connect the points with a straight line with arrows on each end. Number 2, what am I using to find additional points? The slope. Good. Use the slope of the first equation to identify additional points. So I have graphed my y-intercept. Now I use my slope. Do I go up and make a point? Down? Where am I going? Using my slope. I graph additional points. Now, step 3, what do I graph of the second equation?
Y-intercept.
Y-intercept. So number 3, graph the y-intercept of the second equation. Once I've done that, step 4, use the slope of the second equation to identify each additional point. So where we are so far, we're identifying the y-intercept and the slope of a line. Then I said to add the notes, write both equations in slope-intercept form. Step 1, graph the y-intercept. Step 2, use the slope to find additional lines. That's for equation number 1. Numbers 3 and 4 are dealing with equation number 2. Graph the y-intercept, use the slope to find additional points. Now remember, once I've graphed my points, I connect those points with a straight line and put my little arrows on the end. Number 5, identify the ordered pair where the 2 lines intersect as the solution. So I write my solution as an ordered pair where they intersect. After that, though, I said if the lines do not intersect, they are parallel, so there is no solution. If the lines graph on top of each other to form the same line, the solution is all real numbers. So number 5, the first blank is intersect. The second blank is no solution. The last blank is all real numbers. So we're going to use these steps to work through some practice. I've got graphing as our first part of practice. Okay, so we're going to be using these steps. So I'm going to be asking you questions about, okay, what do I need to do next? What do I do next? It is 11:10, so the bell should be ringing shortly for a break. There we go. Take a break. I gotta step out a minute. It's hot. How you doing? That's fine. I got the text from your mama. Yeah.
So I broke my finger on Tuesday, and so I was at the doctor all day today on Tuesday, and then all day on Wednesday. So I couldn't really do it, and when I got back to it,
Oh man.
So I was really confused on what to do because I hadn't done it since Monday.
That's okay.
And so I still have like some of it completed.
Okay. So what you're gonna do is now that we've got these notes, this will help you with that homework. Okay. So use your notes on graphing to help you with that. We already did this. Whoops, that's not the one. Yeah. So we already did this one and we said we had to divide that one to be able to get to y. We're gonna have to do the same thing to that equation. Okay, so that's gonna be similar. Each of these I can solve for y, solve for y, solve for y, solve for y, y. Okay,
Yeah, that's what I've been doing.
Good. yeah. So remember you're going y equals mx plus b. Use the y-intercept and the slope to graph one line. Use the y-intercept and the slope to graph the second line. Your solution is where they intersect. Okay, so as you're working through these, if you need help, be sure to let me know, okay? And we can Zoom or do whatever we need to do.
Yeah, I came back to it and I was like, what do I do? I had to go look back at the lesson in my notes, and my mom was like, I can't even read your handwriting. And I was like, I probably should have sharpened the pencil before I took them. Yeah, I was trying to catch a pass and I caught a really bad one. It bent my finger sideways. And my teammate said he heard a snap when I caught it. So I'm not gonna be able to play until next week.
Mark, I've broken 3 fingers playing basketball.
Oh no, Zoe Watley.
Yeah, I heard my mom talk about it in my mom's class, but I didn't know how serious.
Hi, Mark.
Hello, buddy.
Hi. Did you hurt your finger?
Ooh.
Oh,
I
no.
broke in 2 different places.
Nice. Oh. I've
Because I
injured
caught
like
it really
3
bad
fingers.
pass.
That's how I broke all 3 of my fingers too. It's always the pass.
Yeah, well, this wasn't like a bounce pass. It was like a chest pass, but it was really fast. And so I
Well,
just reached out for it.
Pass for hard, so she keeps breaking my fingers.
So, like, who was throwing the pass? The opposite team or your team?
My team.
Who did it?
You're lucky.
I just throws it, and I hear this pop. Yes, I was at the doctor's office all day yesterday and the day before getting x-rays.
Ouch.
Yeah. But I can't play this week, but I can play next week. So I had to wear like one of those little metal things that you put over your
Yeah,
finger.
the splint.
Yeah, I had to wear one of those for 2 days.
Ooh, I did
Now
not
just
like
tape it. Yeah, now I just taped it up. It's a lot easier.
We have like this finger ice pack. You can probably find one at like Walgreens or something. If that would help.
Well, I have a bunch from like football and stuff.
Oh, okay.
So I use those.
Did you hurt the bone, or is it also you hurt like the tendons and stuff?
It's the bone and the plate where like growing develops and stuff.
Mm.
So if I didn't get like the tape and keep it upright, it would have deformed and it wouldn't grow properly.
Ew. You don't want that.
Yeah, see, I'm like never really get injuries. I get like those I get like the sprained ankles and like the twisted stuff. It's always feet related problems, never upper body.
Mm.
I broke a part of my ankle one time
Oh,
Ooh.
in basketball.
Hi, Mark.
Hi, Chad.
You sound so excited.
Come back. How do you know that? Mark, Taekwondo. Mark. I don't know if he remembers me. Mark.
What?
Do you not remember her? Taekwondo?
No.
Hi, Zoe.
Hi. We'll feel better, Mark.
Yeah, praying for you. Hope you feel better.
Mm-hmm.
Get your head too. Never got to say hi to you and everyone else who's on.
I hope you can play next week.
Oh, Zoe, how did Micah do?
with what exactly?
With his test.
The results haven't been brought back.
Technically, if you got in here for 12 minutes, we can't. I was like, 12 minutes, but we're allowed to.
Yeah, two of our friends already positive. So.
I don't know why it's a rule. If the teacher doesn't get into the classroom for 12 minutes after the class starts.
She's not gonna be in the bathroom for 12 minutes.
That would be a very long time.
Well, she's not even in here that I ran around the whole school.
He's in the bathroom.
Yeah.
Oh, she's coming back, dang it.
I totally just wanna go home.
I am home.
I mean, my home is more like that.
Yeah, but I don't have one.
Yeah, you can't do anything.
I usually ground it.
Oh yeah.
I don't really get grounded
All
anymore.
your fitness.
Yeah.
Okey-doke.
Cat even there.
We are gonna get back to, now you have your steps to use to practice. You have your steps listed out to prepare for the test. You have the steps listed out if you need to correct any homework, okay? You've got them to use, okay?
Oh, yes.
I didn't just have y'all write them out just to make y'all write them out, okay? Use them to help you. Okay, so let's go ahead and look at number one. Number one, what is the first thing that I need to make sure of? When I'm graphing, what do I have to make sure of? What form do my equations need to be in?
Y equals
Y equals mx plus b, slope-intercept form, are they?
Yes.
Yay, let's work. Okay, if they're already in slope-intercept form, then let's work. If they're not, you need to put them in slope-intercept form. All right. All right. So now that we have in y equals mx plus b form of equation one, I have y equals x plus 2. And my second equation is y equals 3x minus 2. How would I be able to look at this and immediately know that these were parallel lines?
What is subtracted? So that would make it a negative version of the other one.
Well, but what part of my equation can I look at to determine if I have parallel lines? What do I know about the slopes of parallel lines? They are the
Reciprocals?
No, negative reciprocals are perpendicular lines. Parallel lines have these same slopes. Because remember, my slopes have to be the same because they've got to be the same distance apart the whole entire way. Okay? You will need to know same slope for geometry. We deal with slope a lot in geometry. Okay? So this is something you need to get comfortable with the information about slopes. Okay? So parallel lines have the same slope. So if I looked at this and I said, hey, I've got parallel lines, I'll automatically know what my answer is because what would my answer be if they're parallel? What did you write on your answer sheet? If they're parallel lines, what's your solution? No solution because they're not going to intersect anywhere. All right, so my first equation, y equals x plus 2. What is my y-intercept?
0, 2.
What is my slope? M equals 1 over 1, which is -1 over -1. So I can either go up and right or down and left. What is my y-intercept for equation 2? 0, -2. What is my slope? 3 over 1, which is the same as -3 over -1. So I can either go up 3, right 1, or down 3, left 1. Okay, so go ahead and write those down. Write down slope, y-intercept. What is the first thing I do? Look at your graphing definition or directions. steps. I graph the y-intercept of equation 1. What is my y-intercept of equation 1? 0, 2. Remember, this is going to go along the y-axis. I do not move right or left, so I start at my origin and go up 2. So there is 0, 2. My slope is 1 over 1 or -1 over -1. So I'm just going to go up a few. I'm going to do 3 up and 3 down, and then hopefully we'll see if we have to adjust, we can. So I'm going to go up 1, right 1, up, right, down, left, down, left, down, left. I'm going to connect my points. All right. Notice, remember, a positive slope means I'm going to start low and go up that way. Positive slope, since my slope is a +1, it's going that way. Negative is going to go from top to bottom. Okay. My next one has a positive slope as well, but what is my y-intercept? 0, -2. So I start at my origin. I do not go right or left, but I go down 2. 1, 2. Okay, so there is my point 0, 2. My slope is -3 over -1 or +3 over +1. Which one of those do I want to do? I want to go positive, because if I go negative, I'm going down in this way, and I'm going away from this line. My whole point is to make them intersect. So I start here, and I'm going to go up 1, 2, 3, left 1. No, wrong way. 2, 3.
It's the right one.
Did I write everything right? 3x minus 2, x plus 2. Yep. Okay, so 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So now I can see where those intersect. It was kind of hard to write on these little groovy things. Okay, so I can see that there's my point of intersection. Now I've got to look and see what is pair for that point of intersection. Start at my origin, and I'm going to the right 1, 2. So I went right 2, so x is 2. And now I go up 1, 2, 3, 4. So my ordered pair solution is 2, 4. Is everybody good with that? Awesome. So now what I want you to do is I want you to do numbers 2 and 3 on your own. Number 2, notice I'm already solved for y = mx plus b, but look at number 3. My first one is y = mx plus b, but my second one is not. So I'm going to have to solve for y = mx plus b. Go ahead and work on numbers 2 and 3. If you have questions, let me know.
Just 2 and 3?
Yeah, just numbers 2 and 3 right now. Just graph those.
Wait, which like lesson are we on?
We're on the graphs. We're graphing. We did number 1 together, and now we're graphing. You're doing numbers 2 and 3 on your own.
Oh.
Okay. So the first one we looked and we intersected at 0.24. But what did we notice about numbers 2 and number 3? They're both parallel lines. So what are my answers? No solution.
Mine are like, they're both parallel, but they're like more sideways.
Okay, so let's take a look. If this is 2 over 1, that means I go up 2, right 1, up 2, right 1, up 2, right 1.
I'm going right to.
Okay, so remember when we do slope, it's rise over run. I have to go up or down first, then side to side. Okay, so check yours and see, did you go up 2, right 1, or down 2, left 1 on each of those? And like I said, you can see here that my slope of both of these is a positive 2. So they're already going to be parallel lines. I knew value is 2. Again, on this one, when I solved my second equation for y equals mx plus b, I ended up with y equals negative 3x minus 4. So both of them have a slope of negative 3 or negative 3 over positive 1. So I can either go up 3, left 1, or down 3, right 1. Any questions about graphing? Does everybody feel a little bit better about it? Solve for slope-intercept form, graph the y-intercept, use the slope. Okay, so that's all you're going to be doing on that. Let's go ahead and look at number 4. Number 4 says solve the system of equations by using substitution. Flip back to your notes real quick about substitution. Let's review those real quick. What are we solving for? What kind of form do we want our equations to be in the beginning? Slope-intercept form. So again, the first thing, I'm going to go y equals mx plus b. Then, after I'm in y equals mx plus b form, what do? I set what equal to what?
MX plus B.
The mx plus b part. Whatever follows my equal sign, I set those two pieces equal to each other. Okay? So whatever I have y equals, whatever is past the equal sign, I'll put equal to the other equation, whatever is past the equal sign. Okay? So by doing that, I have already eliminated my y value, so I'm solving for x first. Then I plug in the value of x to solve for y, write my solution as an ordered pair. So let's go ahead and do the first one together. So remember, on a test, on your homework, on an assignment, I need to see your work. So the work that I'm walking you through and showing you how to write up here should be what you're writing on your paper. And that is a sample of how you do your test and your homework. Okay? Okay, so let's go ahead and start with number 4 is at the bottom of your graphs. Number 4 is just below your graphs. So number 4, I have y equals negative x minus 6 and y equals x minus 4. Step 1 was slope-intercept form. I'm already there. Okay, nothing I need to do there. So what needs to be equal to what? What is on the left side of my equation? Negative. Remember, I'm setting this equal to this now. Negative x minus 6 is equal to x minus 4. That's the mx plus b portion of each of these equations. If it helps you to put a little bracket around what needs to be equal to each other, to go ahead and mark it. That way you remember I'm putting this equal to this. So that's what I've done. What am I going to solve for now? X. All right, so I'm going to subtract x from this side, subtract x from this side. So I have negative 2x minus 6 equals negative 4. Now I need to add 6 to both sides. So now I have negative 2x is equal to, what is negative 4 plus 6? Positive 2. Divide by negative 2, divide by negative 2. X is equal to? Negative 1. So I found my value of x. X is equal to negative 1. So you should be writing this on your paper. You should have that written down. What do we do now with negative 1? I'm going to plug it into one of my equations. I'm going to use this first one, and I've got y equals negative x minus 6. X is negative 1, so I'm going to have y equals minus x. X is negative 1. That's why I put it in parentheses. Negative is part of my equation, so I have to make sure it is down here. X is a negative 1 minus 6. So what is a negative 1? The opposite of negative 1 is a positive 1. So now I have 1 minus 6. 1 minus 6 is negative 5. Now I have y equals negative 5. So now I need to write my solution as an ordered pair. So, whoops, I'm going to have negative 1, negative 5 is my solution. Any questions about that? First, we made sure it was in slope-intercept form. Second, we set the mx plus b portions of the equations equal to each other and solved for x. We plugged our value of x in to solve for y. Ordered pair solution. Turn over to the back. You've got numbers 5, 6, and 7 that I want you to work on now. 5, 6, and 7, you're working now. First step, solve for y equals mx plus b. Look at number 7. What are you going to have to do for 7 to get y by itself? I've got 2y, 2x, and 12. What am I going to have to do to each of those? Divide everything by 2 to be able to get y. Yes. Okay, I've got to solve for y. Remember, I've got to, if it's not in y equals mx plus b form, I've got to solve for y. So how do I get y by itself? Okay, so go ahead and put minus x. Okay, so what do you have over here? Good. Okay, so now how am I going to make that positive? Perfect. Good job. For the first one, you've got to solve your second equation for y. How did you move this x? Yeah. So see if that helps. If you need help, please let me know. need to look back at your notes, look back at your notes. So when you subtracted that, okay, so I've got to get rid of my negative. So remember, all I'm doing, if I take the opposite of this term, I have to take the opposite of that and take the opposite of that. So y becomes what? Positive. Negative x becomes, and plus 4 becomes, there you go. Stay back there. Okay, so let's take a look at this. We have 2x minus 10. Actually, okay. What is a positive 10? Negative 8. Yeah. So if you added 2 to negative 4, what should this be? So to move this from here, what did you do? What is it over here? It's positive and negative. How do I move it? I have to subtract x here, which means I have to subtract x over here. So I've got negative y equals negative x. Yeah, so negative x plus 4.
I have to change the sign of this to positive, so my negative becomes a positive, and my positive becomes negative. So over here, I'm gonna have 3x minus 2 is equal to x minus 4, right? So you subtracted x and subtracted x. This is positive, right? So what is 3x? I can't do both of them at the same time, so I pick one. Okay, so I'm going to subtract this x and subtract x from over here. What is 3x minus x? 3x minus 1x. 2x. So you should have 2x minus 2 is equal to negative 4. Okay, okay, so right here, you subtracted x from this. So what do you have here? Equals. If I move this, if I subtract x over here, I have to subtract x over here. Remember, property of equality. So now I've got the negative x is equal to negative x plus 4, because this is positive, so I have negative x plus 4. Okay, so now to make this positive, I'm going to have positive y. What does my negative x become? Remember, I'm just changing my signs. I'm changing the sign of this one, changing the sign of this one, changing the sign of this one. So negative x becomes x. Y equals x minus 4. Good. So now over here, I've got x minus 4 is equal to 3x minus 2. So the next one is 2. Well, I guess was that before already? Okay, so x minus 4 is equal to, okay, so now what do you want to do first? You want to move the 4 or do you want to move the x's? Okay, so let's add 4 to each side. So what is negative 2 plus 4? I can erase this down here. Okay, so what do you still have left over here? Okay, so x equals 3x. And what did you say this is going to be? Good. Now I need to move this guy over here. So how am I going to move him? Good. So what is x or 1x minus 3x? Good.
I know. I really choose probably.
Okay, so that's going to be negative 1. Now, once you take this right, okay, so I'm sorry, y equals 3x minus 2. Okay, now I'm going to rewrite this, but I'm going to put in parentheses that negative 1. So y equals 3 times negative 1 minus 2. What is 3 times negative 1? Okay. Negative 3 minus 2. So y equals negative 3 minus 2. What is negative 3 minus 2? Good. You can say negative 1, negative 5. Notice that numbers 4 and 5 have the same answers. Number 4, the one we did together, my solution was negative 1, negative 5. The one we did together on the board, my solution was negative 1, negative 5. That was the one below my graphs. Then when I did on the back side, now this one was kind of tricky. Because what kind of sign do I have in front of y in that second equation? Notice I've got y equals 3x minus, and then I have x minus y equals 4. I have to have both equations in y equals mx plus b form. This one already is, this one is not.
So on this one, I've got to solve for y. To do that, I need to subtract x from each side. So I'm left with negative y is equal to negative x plus 4. Check your signs on that. All I did was move my x by subtracting. I subtracted because it was positive. But when I move that, remember, I've got to pay attention to the sign that is directly in front of each term. This is a negative y. So I need this to be a positive y. Remember, I can just change the sign of each term, and that's the same as multiplying or dividing by -1. Negative y becomes positive, negative x becomes positive, plus 4 minus. Now I can set this part of my first equation equal to this part of my second equation. So 3 is 2. I can start moving things from side to side to solve for x.
Wait, can you?
Y'all know I like to move my x's first. -4. Then I'm going to add 2 to each side. 2x is equal to -2. Divide by 2, divide by 2, and x to -1. Questions?
I'm not really understanding these problems. Could you maybe like walk me through this one?
I agree with Chad. I was just gonna wait until after the Zoom to say it.
Okay. Did y'all go back to your steps that we wrote in our steps?
Yes.
Okay. Did you make sure that both equations were in slope-intercept form?
Yes, ma'am.
Huh?
I don't.
What does
really-
step 1 say?
I got mine into slope upper.
What does number 1 say? Okay, y'all listen. What does number 1 say?
Identify the y-intercept and the slope.
No, honey. Number 1 on substitutions. Substitutions. Are y'all on the right set of notes?
I'm on it now.
Yes, ma'am.
Use the method.
Okay, so on notes, it says, what is step 1? I need to solve for slope-intercept form. That is y equals mx plus b. So the first thing I did when I looked at this right here, my first equation is in y equals mx plus b form. My second one was not. So I had to solve for y. Are you with me so far?
Yes, ma'am.
Does anybody have a question on how to solve for y? So the first thing I did is this one was okay. That's why I put a check mark by it because it's good to go. This one I needed to solve for y, so I did that here. So now it's good to go. So that was step 1 in our directions that we wrote right here. Now step 2 says use x plus b part of each equation and set them equal to each other. So that is this part of equation 1 and this part of equation 2. So that's this right here. This is step 2. Okay, step 1 was to make sure they're in y equals mx plus b form. Now I had to set them equal to each other. Is everybody good with that so far?
What do you mean? What do you mean set them equal to each other?
Okay. Remember, the whole purpose of this was some form and I equals mx plus b. This is mx plus b. Are you good with that so far?
Sorry, the Zoom's like cutting out. It was freezing
When I
up.
put this in y equals mx plus b left-hand side, huh?
I said the Zoom keeps cutting out and choppy, so that's why we're having trouble. And now you're frozen.
Yeah, your screen is frozen.
Yes.
Yep.
So for both the right side of my equation, is equal to x minus 4. Is everybody good with that? Okay.
Okay.
Once I have 3x minus, huh?
Oh, the Zoom, your screen keeps freezing. I can't see what you're writing.
Okay, so what we're gonna have to do with
And the audio cuts
and we
out.
have limit range. So what I'm going to recommend is if it's cutting out, you're going to need to go back and watch the video because it will be recorded. Okay, so go back, watch the video for anything that you don't understand, because I can't do anything about the internet connection. So if you
Okay.
cannot hear me the whole way through, you may have to go back and rewatch the link. Okay, so we set them equal to each other. Now I have both x variables. I can solve for x. My next step is to plug x in. And so I take my equation, y 3x minus 2. I'm now going to substitute the value for x into this equation. So I have y is equal to 3 times -1 minus 2. So y is equal to -3 minus 2. Y is equal to -5. My ordered pair solution is -1, -5.
Would it have mattered if we moved -3x to x?
No, because if you would have said you want to move the 3x by subtracting, okay. So if I had 3x minus 2 equals x minus 4, and I subtract 3x and subtract 3x, -2 is equal to -2x minus 4. So then I would add 4, add 4. I'd have +2 is equal to -2x, divide by -2, divide by -2. -1 is equal to, whoops, that's wrong. -1 is equal to x.
So, what does it mean to set those part of the equation equal to each other?
Okay, so do you understand that when I have these both in y equals mx plus b, this equals y, right?
Yes, ma'am.
Okay,
Yes.
so if these are both equal to y, then that means that this is equal to this. Are you good with that?
Yes, ma'am.
Okay, so if this is equal to this, then I set them equal to each other. Are you good with that?
Oh, so you combine them? Oh,
Yes.
I get this
take
now.
this part of this equation and this part of this one and set them equal to each other.
Oh, okay,
I put
I
one
get
on the
that. I
left
get
side of
that
my
now.
equation, this one on the right-hand side. Now I have x in both of them, so I solve for x. Plug in my value of x and solve for y.
Okay, yeah, I get it now.
Okay? All righty, let's look at number 6. All right, for number 6, we have y equals 2x minus 10 and y equals 4x minus 8. They are already in slope-intercept form. So I'm going to take this part of my first equation, this part of my second equation, and put them equal to each other. So 2x minus 10 is equal to 4x minus 8. Okay? Now I'm going to work with my x terms. Subtract 4x, and 2x minus 4x. 2 minus 4 is -2. So I've got -2x. Minus 10 is equal to -8. I'm going to move my 10 from the left to the right by adding, -2x is equal to -8 plus 10. Take the sign of the larger, find the difference. So I have a +2. Divide by -2, divide by -2. X is equal to -1. N.
But why when you make it
So now I'm going to plug that -1 into my.
Why when you make it equal to each other? Why when you make it equal to each other, the x is negative? Like why is the two? Why is the 2x negative?
Part of the equation don't have a -x. I have 2x minus 10. Hold on. So hold on. I have 2x minus 10 is equal to 4x minus 8. Now, when I get to this next step, remember my goal is to solve for x. So I have to have all my x terms on one side and my other numbers on the other side. So I chose to subtract 4x from the right move it to the left. So when I subtract x, that side cancels out, so all I have left over here is a -8. If I subtract 4x from this side, I subtract 4x from this side, and 2 minus 4 is -2.
Oh, that makes sense.
So 2x minus 4x, -2x. Are you good now?
Yes.
Now remember, I could have, if I had 2x minus 10 equals 4x minus 8, I could subtract 2x from this side and have -10 is equal to positive 2x minus 8. Add 8, have a -2 is equal to positive 2x, divide by 2, and -1 is equal to x. I'm still going to find that x is -1 no matter which I moved from what side to what. As long as I use the correct properties of equality, I'm going to end up with the same solution. So now if x is -1, plug it in. So y equals 2x -1 minus y equals 2 times -1 is -2 minus 10 is -12. So my solution is -1, -12. Any questions? Everybody good? All right. Are we sure? Okay, number 7. Woohoo! Number 7. Yay! All right. So again, first step, y equals mx plus b. Uh-oh, my first one is not solved for y, so I have to solve it for y first. Okay, so number 7, I have 2y equals 2x plus 12, and y equals -2x minus 3. Again, this one is in y equals mx plus b form. This one is not, so I've got to solve this one. So I'm going to come over here. If I need to solve for y, what do I need to do to 2y to get y by itself? Divide by 2. So if I divide 2y by 2, then I have to divide 2x by 2 and 12 by 2. So 2y divided by 2 is y equals 2x divided by 2 is x, and positive 12 divided by 2 is positive 6. So did you get y equals x plus 6?
Yes.
All right. This is my mx plus b part. This is my mx plus b part. So I'm going to set them equal to each other. X plus 6 equals -2x minus 3. Everybody good so far? Okay. I'm going to take my x's on the left-hand side. You can move yours to the right-hand side. It's up to you. I'm going to move this one first. So I'm going to add 2x to each side. So x plus 2x is 3x plus 6 equals -3. Now I'm going to subtract 6 from each side. And 3x is equal to -9. Divide both sides by 3. And x is equal to -3. So now I found that x is -3. I'm going to plug that in to my first equation. Y equals x plus 6. So y equals -3 plus 6. And -3 plus 6 is +3. So my ordered pair solution is -3, +3. Questions? All right. So here's the deal. We still have not worked on this third part. Okay. This is where we will start on Monday. On Monday, we are virtual. So on Monday, we will start with reviewing solving systems by using elimination. That'll be the first part of Monday. You will have your test emailed to you on Monday after class, and it will be due on Thursday. So on Thursday, you will have your notes that we just did today will be due. Any work that you have not turned in yet for this chapter will be due, and your test will be due, but I will send out a complete list of everything that you should have to me, what I have from you and what I'm missing from you. You will know to get that to me by Thursday. So if you did not have work that you were supposed to turn in Monday that you did not have, and you want to turn that in, you can give me that. If you are ready to turn in today's homework, you can give me that. If you need to make corrections or finish it, that's fine. Just know it's due next Thursday. We've got 1 week to wrap this up, okay? All right. So if you have questions for other or corrections, so if y'all got stuff you need to turn in,
Yeah.
thank you.
Yes.
All right. So, if questions, be sure to let me know, and we'll try to talk with it. It's not quite so noisy. So on Monday, we'll all be virtual. Do what?
I got the graphing problems wrong on part 1. I think mine were off. I didn't know why. They looked right to me.
Okay, so what I'm going to be doing is as soon as the video is available to publish, I will go ahead and put the link up and I will email it out. So if there's anything that you did not catch while we were live, you can go back and rewatch it. Okay, so go back and rewatch the video. If y'all have any questions, let me know. Okay, thank you guys, and I will talk to y'all soon. I hope y'all have a good afternoon. Everybody stays safe and well. Thanks. We're moving tables. All right, bye guys.
How you doing? The only one over there.
Evelyn.
Sorry.